the dark background, it got harder to see. So we have pie. The Centers for Disease Control and Prevention tracks cigarette smoking in the United States. How has the percentage of people who smoke changed since the danger became clear during the last half of the 20th century? The scatter plot, page 214, shows percentages of smokers among men 18 to 24 years of age as estimated by surveys from 1965 through 2004. So it's got, well, a chunk of, things on it there. So you can see that, page 214. So is there a clear pattern? Describe the trend.
No. It's kind of like this little curve thing.
Yeah.
It goes down and then it kind
goes
of
back up a little
flattens
bit,
and goes
but
up.
then there's some ones that go down.
So, yes, the percentage of smokers
Look at the pictures.
was at a steady decline until it looks like around 1990. Where there was a slight increase. Is the association strong? What kind? What would we call that? What do we call that shape? Yes, strong parabolic association. Is a linear model appropriate? Explain.
No.
Why?
It's not linear.
Huh?
It isn't linear.
Yep.
Just abbreviate it.
No.
So,
What do you abbreviate?
no, because the shape of the scatter plot
Oh. I think you abbreviated something else.
shows parabolic model.
I can see how this section might be kind of hard to test math wise. I feel like this is more of a concept thing.
Yeah. That's why I need to look at the thing because this might have been more of a concept heavy test than I have to look. But I also have to either draw in all the scatter plots or find problems that, because, there's a test generator, which is where a lot of the problems have come from in the past. But the problem with it is that copying and pasting, the scatter plots in, they don't always paste correctly, and, the formatting is weird. So some of them, look kind of funny. So it doesn't always,
Okay.
Yeah. Anyways. So 4 is going to have a super weird scatter plot, which you can probably also see why it would have been hard for me to draw these in for you. I was going to, and then I went back and I looked at them, and I was just like...
Yeah, it's easier to just look at the book.
Yeah, I was like, I would say just look at the book. If I'm going to pick one, I'm either going to have one that I can copy and paste really easily, or what I have done in the past a few times is I've actually, put my book on the copier, and I've, scanned out the the piece that we needed, and then just
Really?
cut it. Yeah, because it just can be difficult. So anyways, so the United Nations Development Program, UNDP, uses the Human Development Index, HDI, in an attempt to summarize in one number the progress in health, education, and economics of a country. The number of cell phone subscribers per 1,000 people is positively associated with economic progress in a country. Can the number of cell phone subscribers be used to predict the HDI? Here's a scatter plot of HDI against cell phone subscribers, aka page 214. Explain why fitting a linear model to these data might be misleading.
Because it's a bit further.
Okay, so it doesn't follow a linear pattern. It kind of levels off. So it kind of starts like on an increase and then it kind of just like levels out there. Can you think of another type of graph that might fit that data better? I'm looking at you back there.
Square root out there. I mean, that's what it makes me think of, anyways.
You might have to think of one that has been reflected.
What'd you say, Melvin?
Well, I was looking at Josh because we just did the 12 basic functions in pre-cal, and it is one of them. But if y'all remember the 12 basic functions, then
Like, I was gonna say it was like the square root function.
nope. What's something that, like, levels off?
The exponential function? No.
Opposite of that.
The natural.
Yep, natural log. Okay, it would be better modeled by a natural log. Okay, because remember, in general, a natural log does this. Okay, so that's why I said it's kind of like reflected because it's like flipped over. Obviously, in this case, it looks more like that. So then part B, if you fit a linear model to the data, what do you think a scatter plot of residuals versus predicted HDI will look like?
Maybe you can force it into a linear model.
So basically, if you drew a line through it
It'll be like
to
a
summarize the data, what do you think would happen?
I think the residuals might look like a hill, something.
So what do you mean? Don't just tell me it looks like a hill. Explain it.
Like,
Because I think you might be on the right track, but
I
I'm
don't
not
know-
sure.
I don't know if my mind is thinking like reverse of what it would be, but like I'm gonna go with like some of them are like lower. It starts out like being pretty close to what it actually is. Then the residuals start to get bigger in the positive direction, and then they kind of go back to being close to zero.
Basically, yes. So the residuals are going to be a mix of positive and negative. But eventually, most will be negative. Okay, because if you draw a line through that, you probably are going to end up with more points on the negative side than you have on the positive side. And residual is basically how far it is from the mean, in a sense, not, actual minus predicted.
Oh, I see. That's true.
All right, now 7 is one of your homework problems. 8 goes with it, so we're going to try to do it. I don't think we need 7 to do 8. I don't think it matters. If it looks like we do, then we'll pop back and look at it. But I think we'll be fine. All right, so 8. Does the cost of making a movie depend on its audience? Here's a scatter plot of the same data we examined in exercise 7. So it's the graph is a little different, but it's of the same set of data. With movies with an R rating are purple, PG-13 red, PG green. Regression lines have been found for each group. Notice the black points are G-rated, but there were too few to reliably basically make a best fitting line for them, so that's why they're not there. Now, it's probably a little hard to tell some of these colors apart. I think I would have chosen something different, because if anybody's red-green colorblind, they would be really struggling.
Also, that purple thing is really like a red.
Yeah, and the black is kind of hard to see as well, because it kind of blends, but...
Like, what in the Christmas is going on? La, 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 la.
All right, so in what ways is the relationship between runtimes and budget similar for the 3 ratings groups?
They're all positive.
Yeah, so what does that mean in the context?
The higher the budget, the longer the movie.
Yep.
In like fancier terms. But
Yep. Budget increases. I guess budget increases as the runtime increases. Because what's being changed is the runtime, and the budget is getting higher as a result of that.
I mean, that makes sense.
How do the cost of R-rated movies differ from those of PG-13 and PG-rated movies? Discuss the slopes and the intercepts.
The slope of R-rated movies seems to be less than that of PG-13 movies, but more than that of PG movies.
Say that one more time.
The slope of R-rated movies seems to be less than that of PG-13 movies, but more than that of PG movies.
Yes. So they have similar slopes, but the budget of R-rated movies is much lower because it has a lower starting budget. But yes, what you said is true about the slopes. It's a little lower, but also on one than a little higher on the other.
You can look at the graph.
Yeah, what do you mean?
How do you know the slope is higher than one and lower than the other?
Well, as the purple line and the green line goes to the right, they start to get closer together. So that's how I know that PG movies have a lower slope than the R movies. And the red and purple lines go farther apart. So I guess you could finish that. Do you understand that?
Are you sure you understand?
Yeah.
You don't sound very confident.
I'm just
That is Josh.
It's kind of hard because they're not stacked in order, so you're really just looking at the slope itself of what's happening. If you want to get super fancy, the book specifically says for that one, in fancier terms than what we said, although the costs per minute are about the same, meaning they have similar slopes, on average it costs about $20 million less to make an R-rated movie than a movie of other rating types with the same running time. So basically they said in much fancier terms what we said simply. So the film King Kong, with a runtime of 187 minutes, is the red point sitting at the lower right. If it were omitted from this analysis, how might that change your conclusion about PG-13 movies? So basically, what would happen to the slope if we removed that point?
It would increase.
Okay, so the slope would get steeper. And at that point, then we can conclude that the cost per minute of PG-13 movies was greater than that of other movies. Because I think, look back at the key of the colors. I think PG-13 already had the steepest slope of all of them, so if we took that away, it would get even more so. And I mean, it kind of makes sense because overall, people probably are typically seeing PG-13 movies more than R movies. And there's not a whole lot of PG movies, at least in this day and time. They're pretty much all kind of that weird in-between thing. So, I mean, it does make sense they would put a little more money into those type of movies. All right, now, even though we're going to do 12, we're jumping to 18, mainly because I was trying to fit it on the paper without having to have a bunch of free space or move a problem onto different pages. So, that's why they're out of order. So, this one's fitting for all of you doing college applications right now. A college admissions officer defending the college's use of SAT scores in the admissions process produced the graph below. It shows the mean GPAs for the last year's freshmen grouped by SAT scores. How strong is the evidence that SAT score is a good predictor of GPA? What concerns you about the graph, the statistical methodology, or the conclusions reached?
I hope it's not strong, because my SAT was not equivalent.
Well, it looks pretty strong to me.
No, I'm joking. It was impersonal.
Ooh.
Okay.
Sorry, Peyton.
Never mind. Okay.
Are you okay?
Yes.
Well, yeah, that also.
I was just trying to
It's
make
also
a
very
joke.
different.
Yeah. My ACT was fine, but SAT, no.
I feel
What do you notice about this graph?
It's a
goes up.
line. That's lines.
What kind of graph is this?
It's not a scatter plot.
It's not, no.
Oh, hey.
It's not
Working on hard.
Oh, yeah,
There should be only 5 brushes, I think.
that's fine. If they're not going, I'll just save them for later, but
Okay.
anyways, thank you.
Step line.
What am I wearing? I can't remember what it's
I
called.
don't remember what it is, but I can say it's not a scatter plot with
Yeah.
absolute certainty.
It's not step line, is it?
What should it be, I should say, maybe.
Scatter plot.
Okay, it should be a scatter plot, but it's not, right? Why?
Because they drew lines to connect the dots.
They connected the dots, so it automatically can't be a scatter plot. It looks relatively linear, right?
Yeah.
But how many points are on there?
7.
7 points. And how many freshmen do you think probably
A lot more than 7.
A
a
lot
lot
more
more
than
than
7.
7, right? So I would say that this admissions officer picked a few people that met what he was trying to prove and
Yeah.
used that data only. And we can't do that. So some things that I would say is it's moderately strong because it's fairly linear. But the graph should be a scatter plot. With dots that are not connected. And then I would say something like, it appears the admissions officer
It's defective.
chose data to quote unquote fit his model.
Okay, so he was trying to prove that SAT score is a good predictor. So.
Of GPA. So my understanding is that this is the freshman GPA in college.
Yeah.
That whatever their SAT score is a predictor of how they did in college. But mine didn't fit that. I mean, that model. Most people's probably doesn't fit that model. He basically was like, I want to try to say this to try to say SAT scores really matter.
Yeah.
I just personally don't think that they
Because, you know,
are a good indication, but
I think it's, according to this graph here, I have a 2.5 GPA.
Yeah, same.
So,
I don't like how you tried to predict the.
I had like a
GPA.
2.35 according to that
I like how
graph.
someone almost gets a perfect score and they still only have a 3.25.
yeah, like what? Who did you
Exactly.
ask?
It's because they're majoring in like aerospace.
Red flag.
Or something.
Red flag.
Pink.
Well, also not to
Pink
mention
flag.
gen eds should be freshman year, so that doesn't really make sense.
Yeah. No.
Minor details. All right.
The 900 might get it. 2.25, but
Okay.
still, no, I don't think so.
All right, number 12, I think, is the next one. So this one, I've laid it out kind of interesting
Okay.
because basically each question is going to have an A, B, C, D underneath of it,
You're
Oh, right. Yeah.
but it's short answers. Okay?
Yeah.
So, like the first, so it says each of the following scatter plots shows a cluster of points and one stray point for each answer these questions. So it wants to know in what way the point is unusual. Does it have high leverage, large residual, or both? So we're gonna look at each of the graphs. So basically, under each of these, we're gonna have an A, B, and C. Oh, and D. I guess there's 4 of them. And we're going to answer it for each one. So basically, we're going to focus on what way the point is unusual, first of all, before we get into, everything else. So, on A, any ideas?
It's just like really far away from the rest of the data.
Well, yeah, but that's not what it asked.
Yeah, I guess it has high leverage or something.
Yep, it does have high leverage.
Oh, do we have to do this for like
Does it have an
which? Wait, are we
outlier?
doing this? Is this for?
For A, for graph A.
And I'd say
It's the blue dot
Does
graphs.
that have an outlier?
I'd say it's like a low residual.
We're not doing outliers yet.
Oh.
What'd you say?
Low residual.
And it makes a large residual a bit smaller with where it is. I would be more concerned personally if it's high leverage or low leverage. I would not stress as much about the residual part. I don't even normally do that part, but
I have a question about leverage. So is that like would high leverage mean that it's just like far away from the rest of the data?
let's go back to the official definition. So, said a point is unusual if its x value is far from the mean of the x values. This is called high leverage. So it was farther away from the x value, like the mean x value of those, which is why it was high leverage.
Oh,
I understand now.
we'll see if I understand that.
So then B,
High leverage.
it is also high leverage. I'm trying to check because I don't usually do the residual part, so I'm trying to check and make sure. That one has a small residual. I'm mainly just writing the stuff about the residual, but we don't usually, like I said, we don't usually do a lot with that, so I wouldn't stress about the residual part. C,
High leverage.
Would that be low because
Or maybe moderate. I don't know.
there's no such thing as moderate. It's either high or low.
is it low because it's so it's based on the x-axis, right?
Yes.
So, like, the
the
middle
mean
of
of
the
the
X
x
is, like, the
values.
same.
Yep. So so that one would be low leverage. And that one has a large residual. Basically, the residual is if you draw your best fitting line, how far away is it from that? And think about if you take it away, what happens, essentially.
Okay. So it's large if it's like kind of packed together and like fits the line. It's like,
Well,
if you
so
draw a
large
line on
residual,
that-
so if you drew the line through that one, those
Yeah.
points almost make a line as it is.
Yeah.
So that one is going to be way off of that line that you draw. So that's the residual is how far it is from that.
Oh. Well, where are we drawing the line?
Through the points. The extra point that's up there by itself is the point we're looking at.
Okay.
So basically the points that are on there, because they do like this kind of,
Yeah.
and then you have this point way up here, or well, I guess it's more like up here. If you drew the line through here, that's a lot farther off, so that's why it has a large residual.
Oh, okay. I see now.
I just figured out my problem. I was looking at the wrong thing.
Were you looking at 11s? The red one? The red
Well,
ones?
good news is that one's your homework, so.
I was wondering about how you guys got low leverage.
Oh, I see. Yeah. I think, yeah.
D,
I'm high leverage.
high leverage.
You looking at the blue ones, Josh?
Yes.
Thank you.
And
Like a small
any
residual.
idea about the residual on D,
Probably small.
just since we're
Small?
looking at it? Yes.
Ooh, yes. That was a little confused about the
I have a
residual
question.
I still don't know what residual is.
So
It's
what's
how
the-
far it is from
I
that
drew a line
main
and it was
line.
basically on the line. The stop was basically like on the line.
But like,
Let me just
where
know.
do you
So
know how to
what
draw
does
the
it-
line?
It's the best fitting line.
Yeah. So like.
The average line, if you took all your points and you drew a slope of that.
Yeah.
The best fitting line that we've been doing for
You draw a line through it.
Yeah, I guessed that on the quiz. I didn't know what that was.
I drew a line.
So what does it mean when you say like makes large residuals smaller?
like if we were to
Get rid of.
yeah.
Cause like I wasn't looking at that one when we went over that. So
Yeah, basically, if we were to draw the line, if we took it away, it would, like, everything would have similar residuals. So that one is just, like, it would be really big. Because it'd be really far off the line.
Below it says it.
But it would make it a little smaller because of where it is. Because right now, my intercept would be, like, below the x-axis. All right. Do you think that point is an influential point?
Yes.
Okay, first of
We
all.
have to do A.
First of all.
Well, of course I'm talking about A.
The red or the blue one?
The blue one.
All right, a point is unusual if, when omitted, it significantly changes the linear model. This is called an influential point. It changes the slope of the line.
Changes it.
High leverage points can be influential, but they don't need to be. Okay, so A is influential, okay, because if we took it away, it would drastically change the slope of the line. Okay, so it is
Correct.
influential.
So they is not
I don't know. I wasn't looking at that one earlier, but now what I'm looking at is just a cluster with the.
So if you
dot.
cover up the dot and you draw a slope of your line, it's probably pretty steep.
Yes.
Okay? If that point is in there,
It changes.
it changes.
So
It goes from
influential.
like this to like this.
Influential.
So it's going to be influential.
I'm gonna start doing that. I'm gonna be like, boop.
No, the one year when I taught this, like they literally were like
Oh, you're taking the tough
like
one.
watch. It was funny.
C is not influential.
I feel like it would kind of influential.
Is it because I
Like
Like,
barely influential.
Yeah, not really. It's not really going to change it, so it's not influential.
thought it was an influential.
It might change ever so slightly, but because all the points are in a pretty tight line, one point isn't going to change that much.
But it's not.
Wow, that was funny.
I don't get PR back. It's not that influential.
How about D?
That's definitely not influential.
No.
Not influential
No,
because
'cause
it's
it's
literally in the
literally-
pattern.
Oh my goodness.
It's a widowy in the line. Found something I can do. Something I can get right.
The influential?
Yeah, proud of you, Josh.
You didn't get this. You didn't get that one right though. You didn't get me right.
Okay, let's take it away from me.
Sorry.
You're offending Josh.
I'm sorry.
Drop all my math classes. I'm just gonna
No.
drop out of school at this point.
Okay.
Drop into a
Okay,
hole.
easy. You already have enough credits to graduate. You just
Yeah,
gotta
literally,
survive.
Literally. We never took government, so we really could have graduated.
I'll just go get my history
Need English.
major at that point, yeah.
We could have done like an online English or something. We could have.
All right. If that point were removed, would the correlation become stronger or weaker?
Absolutely.
Stronger.
Josh, you can't just say yes.
Stronger.
Wait.
That's how tightly packed together the points are.
I know every single word to that song.
What song?
Stronger than ever.
Oh, I was just singing it.
All right.
The line.
B.
Wait, don't we have to explain that?
Do you?
I mean, I don't know how to explain it. Really.
I mean,
Because
I mean, do we
they're
really
all
need
together,
to? Like, if,
but then there's that one that's like, "Hey guys," but then like, if he gets taken off,
hey guys.
then they're all just clustered together, so the correlation would be higher at that
We
point.
should definitely write that down as like our answer.
Yeah.
It officially says
I'm gonna get scientific.
the correlation would increase because the scatter would decrease.
Oh, that's boring.
Yeah.
What would decrease?
The correlation would increase because the scatter decreases. No. Yes. Yes. Yes, that is what it said. All right, B. What about that one? Weaker, stronger?
I think
Stronger.
Stronger.
I'd say.
Yes. No. Weaker.
Wait.
What?
How? Where?
Because the points are super spread out. That one is kind of keeping it together.
Wait, How's it
but
keeping
it's
together?
not
Okay.
even next to that.
Here's what the book says. The correlation would become weaker because the outlier has high z sub x and z sub y values. It's just the reference of that point. Increasing correlation.
Hmm.
I think
Okay.
the book's pulling some
So I guess
tomfoolery
it's a
on us.
positive influence
Yeah,
It's
it's a positive
from a distance.
from a.
because it's an outlier.
Yeah, it is an outline.
So it makes it weaker. If we remove the outlier, it would become stronger.
Wait,
Wait,
wait.
you
the
said it would
answer
become
be
Isn't that
stronger.
backwards?
Huh?
Did you mean to say it like that? You said if we remove the outlier, it becomes stronger. Because then the answer would be stronger.
Wait.
We
Did
are
I say that
looking at
backwards?
yeah, I think so.
So is it becoming stronger? Or-
No, I think it's
No, it is weaker. I said it backwards when I said it.
It's okay. I was like, wait.
You're like that one rap. When she was like, I saw the line.
I saw
and
the
it was
line,
out."
and it was out. And we were like,
We
yes,
said.
that's what we're saying. Wait, I saw the line and it was in. That still made me so angry.
Yes, with it there, it's pulling it together.
Okay.
So if we remove it, it's spreading it out
It'll
more.
spread out more.
Yes.
Oh,
That's what I was trying to say, and I said it backwards.
Okay.
It's like Willy Wonka. Hold that. Reverse that. Let's try again.
Hold on.
Okay. C.
Definitely stronger.
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 What?
The weaker?
No. Looking at what did you say?
I said stronger.
It is
That's-
stronger.
He was like stronger.
Actually, said stronger.
Are you correct? What?
All right. Yes, it is stronger
Because if it
because
let
the
go,
scatter
it'd
would
be
decrease.
fine. Okay. No. Okay.
You wouldn't let
D.
go.
D.
I think it would be weaker
Would it be weaker?
because like.
'Cause I
there's
feel like
this
it's
one guy
holding
who's, like,
on.
It's
holding
weaker.
lines,
Holding
like,
on.
then when you take him out.
It just needs to
all
let
those
go.
It's
others
just
that are
the
being
reverse
backed
of
up.
B, basically.
Yeah. Yeah.
Okay, sure.
Okay, now, if that point were removed, would the slope of the regression line increase or decrease? Explain.
It's a line.
You need to go back to like.
Okay, so for A it would
Sixth grade.
increase.
A would increase, yes.
Yeah.
B.
Increase.
It's a slope, right?
Probably stay pretty close to the same, but decrease slightly.
Wait a minute. Let's go back.
Because right now it's pretty sharp going this way. If we take it out, it's going to decrease a little bit. Doesn't mean like negative, but it's going to go from being like this to being
Are we talking about the same one?
We're on
B.
right?
yes.
That's the one with like that cluster with that one little guy all the way out there.
Yes.
Wouldn't it get steeper?
I thought it was like.
Yeah, I
so-
thought
so
it
we
was
start out
the
like
end.
this.
No,
And then
it
if you
starts
take it
like
out,
this
look at
with
that.
him there, and when you remove him, it goes down.
But,
Because
like,
you basically are splitting the points in half.
I still don't trust it.
You don't trust it? I just don't trust it.
Literally, just
let me
split the
get my-
points in half.
Let me get my line out.
Don't draw the clock.
Like,
Because with him in there, it's like this. We remove him, it comes down like this to split the points. You
Okay.
just can't see it because the pencil's really big.
okay.
So when it says decrease, it doesn't mean like goes negative. It just means that it gets.
Can you
Right,
demonstrate
I
that
was
for
thinking
A?
it would be like go more like vertical because of where all the data is.
Because it would be like this. If you remove him, it would go like this.
Okay.
So it's like
I
there
trust it now.
to there.
I trust it.
Come back.
Put my trust
Come
in
back.
case studies.
There we go.
That's what you're talking about.
Okay. I'm about to leave my book off the side here. So this one would decrease. And I will tell you, it is possible that the answer is stay the same, even though it doesn't tell you that that's an option. C.
That would literally.
Decrease.
Would it decrease?
It would be pretty close to the same, but a slight decrease.
Okay. I was in the right
So it's
direction
still
though.
Sure.
You shouldn't say increase.
Like extreme increase. Yeah.
And then last one, D.
The same.
Good thing.
Yeah, about the same. You could potentially have a slight change, but about the same. Because it would be a pretty steep negative, but if you took it out, it could lower a little bit, but it would be about the same. All right, your homework problems are at the bottom. They all have a scatter plot with them, so I was going to type the questions, and I was like, you're going to need your book either way, so I had other things that were more important to do. And alas, there we are.
Alas.
But 11 will be like what you just did. 17 is very similar to 18. So I tried to pick ones that are similar to what we did. In his shoe?
What?
You found it in your shoe?
No.